So thank you for joining us again. In this video clip, we will talk about the disciplinary core ideas. And to do this, we're going to look at the matrix of these core ideas, which you can find by clicking on the link in the description that goes with this video. And the link is also on this slide. And once you open the document, we want to give you some time to look through it. And there are some questions on this slide that may guide you when you do this. So if you'd like to, you can pause the video now. Okay, so as you noticed, the matrix consists of core ideas in 4 disciplines: physical science, life science, earth and space science, and engineering. And for each discipline, the core ideas are divided up in strands and components. So if you take a look at the core ideas, you may notice that they proceeded with a code. And the first part of the code is the grade of the students. So that could be K to 5 or MS for middle school and HS for high school. And the rest of the coding relates to the discipline, the strand, and the component. And then the final digit is really a sequence number. And we added these codings to the matrix that was originally developed by the National Science Teaching Association as a way to reference these core ideas. And we'll talk about that more in our following videos. The other thing you notice is that each core idea has another coding towards the end in parentheses, and that is a code that refers to the performance expectation. All right, let's look at some of these core ideas. So we go to page 3 of the matrix. In the second row, it talks about conservation of energy and energy transfer. So there are some prompts on this slide. So take some time to do this, to follow these prompts, and pause the video. And when you're ready, you can start the video again.
So we want to take the opportunity to just dig into this row a little bit. And I want to start with this idea all the way on the left side of your matrix, this kindergarten idea of sunlight warms the Earth's surface. To adults, that sounds very simple. Very basic, we know that, but this is actually a really foundational idea, and we're going to talk about how this idea spreads through this matrix. So we need to shift our thinking. Rather than thinking of this as a simple idea, we need to think of this as a foundational idea. This leads to understanding of more complex ideas. And so, for example, we can see, if you look at the middle bullet in the next column, that light transfers energy from place to place. So we're saying sunlight warms the Earth's surface, and the way it can do that is because it's transferring energy from place to place.
Yeah, so energy is a really key idea, and it's really interesting to see how in this grade, energy is related to very concrete forms, either moving objects, so we can see them move, sound, something we can hear, light, something we can see, and heat, something we can feel. So, so that's how energy is introduced in 4th grade.
And so in middle school, we start to get a little more abstract. And if you look at this last bullet in middle school, energy is spontaneously transferred out of hotter regions or objects into colder ones. So we're talking here about why an ice cube melts in water, or why if you're holding a warm coffee cup over time, it cools down. So we're thinking about the flow of energy, which is more abstract, but a really crucial, again, foundational idea to understand how energy moves through a system.
And what's really important in this matrix is that different pages connect to each other. So this idea that Stacey just talked about connects to an idea on page 1 related to properties of matter. And another idea that does this connection, that makes this connection, is the idea just above it, which talks about how much energy we need to change the temperature of a sample of something, let's say water. And basically what it's saying is that if you have more water, you need more energy to change that water by a certain amount of temperature, let's say a degree.
And so again, when we're thinking about energy transfer and energy flow, we also need to think about this idea of conservation of energy. So we're looking really now at these first two bullets in the high school column that, you know, energy, it doesn't spontaneously appear or spontaneously disappear, right? It means that energy is coming from somewhere and going to somewhere. And when you think about energy in this way, you can really start to think about systems, and you can trace how energy flows through a system and creates change within that system.
And I want to move to the bottom of the high school, that last idea, which is really generalizing the idea that Stacy talked about in middle school, the idea from energy spontaneously transfers out of hotter regions into colder regions. This idea in high school talks about systems evolving towards more stable states. And a more stable state is a state, for example, where we're moving from hotter to cooler, but also, for example, where water is flowing downhill. And you see the examples here.
And so we hope this helps you see how interlocked and how supportive these ideas are of one another. We also hope for K-5 teachers, it helps you see how important it is to really spend the time to establish this foundation. But also for high school teachers, you can think about where these ideas have come from and where kids have encountered them before.
And in our next video, we will talk a bit more about how we can use these ideas to construct explanations for phenomena.
Bye, everyone.